Okay, the last property that we're going to look at in terms of transition metals is the idea that they form something called complex ions. Let's take a look at what that means. So if I was to draw out a transition metal such as iron 3 plus and compare it to a metal that is not a transition metal, you would notice that the iron, the transition metal, has quite a smaller radius compared to, say, for example, an alkali metal. And that actually gives it some interesting properties. So because it's so small, it has a dense positive charge. Okay? That dense positive charge means that it can attract anything that is negative. Attract. Okay, so let's take a look specifically at this iron. Say, for example, floating around this iron, we had a water molecule. Okay, so water is made of 2 hydrogens and an oxygen, and this oxygen actually has 4 electrons on it that aren't used for bonding. Now, because electrons are negative, they're actually attracted to this positive charge. And what they do is they can form a bond with this positive charge. And because the positive charge is so dense, iron 3 plus, for example, can actually attract 4 different water molecules. So again, this is iron 3 plus. And what it can do is it can attract 4 different water molecules. 1, 2, 3, 4. And form a complex ion. So we have our 4 oxygen molecules. Now, each of these water molecules has an oxygen that actually donates 2 of its electrons to form that bond with oxygen. The other 2 electrons are just left on the oxygen. So it actually forms a bond by donating the 2 electrons to iron. Okay, and this entire thing has a charge of 3 plus. So it is an ion because it is charged, but it's complex because it has more than a few atoms within it. Let's take a look at each of the different parts. So each of these water molecules, which are bonded to the central atom, the central ion, are known as ligands. So these guys are known as ligands. Let me write that down. Ligands. Okay. The central molecule is also given a name. The central ion is also given a name. It's known as the metal ion or the metal center. Metal ion or center. Okay, and finally, the type of bond that exists between the ligands and the metal center is also quite special. It's known as a coordinate bond. Coordinate bond. So normally when you have 2 atoms bonding, usually one atom gives 1 electron and the other atom gives another electron to form a bond. So let's take a look at carbon and hydrogen. So normally when they form a bond, carbon has 4 valence electrons and hydrogen has 1. If they want to form a bond together, what happens is 1 electron from carbon and 1 electron from hydrogen is donated, and then you get a covalent bond. So it results in this. Okay? In complex ions, that's not what happens. Both electrons that form the bond between the metal ion center and the ligands come from the ligands. So it is a coordinate bond. which means usually ligands in most cases have a non-bonding pair of electrons. So a pair of electrons on an atom within the molecule that are not used in a bond. Okay? Great. How do we write this out if we're trying to write the formula? Well, it's pretty straightforward. In this specific molecule, we have 1 iron and 4 oxygens. So let's write that down. 1 iron, 4 oxygens, and overall, it has a charge of 3+. Okay? Now, sometimes this ion can actually bond with a nonmetal or something that has a negative charge to form a ion. So for example, we could take this ion and combine it with the chlorine 1- ion, and we would get an ionic compound. It would look something like this. Okay, so again, we need 3 chloride ions to balance out the charge of the iron water complex, and that's how we get this formula of the ionic compound. Okay, the last thing we're going to look at is the different types of ligands that we have. So let's pretend that in both cases we have platinum as our central ion. Okay, and let's use chlorine as one of the ligands. So chlorine minus can bond using a coordinate bond to platinum. Chlorine is an example of a monodentate ligand. What does that mean? It means that chlorine is only bonded to the central metal once. So it's monodentate. It's only bonded to the central metal once. So you can probably guess what the other case is. The other case is when we have ligands where we have, let's say we have some nitrogen, let's say we have some carbon, some hydrogen, and some hydrogen. So in this case, this is one entire molecule. This is one entire molecule. And so this one molecule is bonded to my central ion twice. And so this type of ligand is called a bidentate ligand. So this is an example of a bidentate ligand because it's bonded, the same molecule is bonded twice to the metal ion. Okay, so different types of ligands. So let's write that underneath. Monodentate ligand and bidentate ligand. Okay, so once again, transition metals, because of their high density positive charge, can attract almost anything negative, including electrons. What results is coordinate bonds between the ligands that have electrons that aren't bonded and the metal ion, and we form a complex ion. There are 2 different types of ligands that we can look at in IB chemistry. A monodentate ligand, which is where we have our ligands that are only bonded once to our central metal ion. We can also have a bidentate ligand, which is where our negatively charged or electron containing ligands are bonded twice. So the same ligand is bonded twice to a metal ion center.